Hi, I'm Carrie Douglas. I'm a digital teacher librarian with Jefferson County Schools at Dean Elementary, and my project is a makerspace project with second graders in science. This will be a collaborative end of unit project with second graders science. They will have been through an entire unit of cause and effect using forces and motion. So I'm assuming that the teacher will have taught the bulk of the unit, where I would come in and assist with giving the ideas and sharing exemplars for what a makerspace is, and then teaching in this makerspace project of creating a paper roller coaster that would demonstrate force and motion. I'm timing this to be completed in 5 lessons with 30 minutes for each lesson. I originally got this idea when I went to the Denver Museum of Nature and Science Mini Maker Fair early on during the class. The Denver Public Library had a booth there, and they had all of these templates put together with tracks and funnels and curves and columns where people would just walk by and help piece together this paper roller coaster, and all types of people were rolling the marbles through the roller coaster, and I thought that would be a great idea for either second graders or sixth graders at my school. So students will be designing their own roller coasters with a small group. They'll be given pieces like the columns here and supports that would support the columns. We created some funnels. The tracks are red here. There's longer curves and tight curves, and there's a merger under there, and there's a few other pieces. But as I was piecing together an exemplar, this was very tedious work. It was very difficult. Maybe not difficult, but just very tedious. It would take a long time for a second grader to actually cut these out right and tape them together. So between 2 teachers, myself and the second grade teacher, and 2 paras, the second grade has a full-time para, and I have a full-time para in the library. Between the 4 of us, we could piece this together and have it ready for the end of the unit. So this is an amplified project. The teacher would lead with directions and an exemplar and some success criteria with a rubric, and then it would also be student-led by them actually creating the design. They have to take concepts that are kind of abstract and make these concepts physical with cause and effect, with the force and motion of the marble going through the actual roller coaster. The picture here is the beginning of an exemplar that I created with my 5th grade son. Just these pieces alone took us about an hour, because you do have to have the marble go through and it be a successful operation. So while I have it designed for 5 days and 30 minutes, could take longer. So here is the success criteria and the scoring rubric for our second graders. This is a rubric that they would be given at the beginning of the project, so they would know exactly what they need to do to be successful, and it would be with them at all times in their group to help guide them as they do their own design. So here's an actual exemplar that I did with my son this summer. Obviously, he got very excited because we worked very hard on this project. So here are the curriculum and content goals. These are from the Jefferson County School District, second grade science cause and effect unit with forces in motion as the focus. So if I was to score myself right now, I'm doing an oral presentation, so I would get a 3. It is actually, these columns are exactly 12 inches high, so I didn't go above and beyond, but I have at least 12 inches. If I actually took the tracks and I added them together, which would be an application of math, I would know that we are well beyond 48 inches. I'm right at the 20 seconds with my marble, and I do have a bucket at the end. You can see it here. There's a bucket at the end. It's nothing special, so it would also get a proficient. This is probably the most important part, is if a student can articulate the friction points. So frictions that push the marble in a direction that it came from. So that would be our curve, and we really did not do much of one, but it would be one of these two curves that would push it in the direction that it came from. So that would be probably a 2.5 or a 3. Again, this isn't a great exemplar, but I would want the students to know that they'd have to use a curve to do that. Gravity that pulls the marble straight, so any of the tracks would count for that, and I have quite a few of those, so I have more than 5 or more tracks for gravity. And then a force to slow the marble, and there's quite a few points to slow the marble, so I have my curves here. There's a curve here. The funnel would count as a big one, and if a student did a funnel in a successful manner, they would definitely get a 4 because it's very challenging. And then a force to change the marble in a direction, and again, all of our curves, even our loop would force it in a new direction. And since I did quite a few of those, I would probably give myself a 3.5 or a 4 there. So that's how we would score it. And again, I would go through this exemplar with the students, saying this is a small version of what we would hope that the students would do. So thank you for watching the presentation. I used the Explain Everything app, which is an oral presentation tool that our students could also use, because we have 3 class sets of this app that our students could use on their iPad. So this would be a way to incorporate technology at the end of the project. If a student is really advanced and their group has gone through pretty quickly, that would be a great differentiation tool. Thank you.